Section 3.3 Zeros of polynomial functions. Factor theorem. For any polynomial function f of x, x minus k is a factor of the polynomial if and only if f of k equal to 0. Let's look at this example. Let's say I have a f of x squared minus x minus 6. Okay, since this is a quadratic equation, I could just factor out using the x method. So that will be x minus 3 and x plus 2. Okay, when you distribute it, use the FOIL method, you're going to get back the x squared minus x minus 6. And then factor theorem saying that if x minus k is a factor of a polynomial, so this is called the factor. X minus 3, this is the factor of the fx. X plus 2 is also the factor of the function x. If we could plug in f of k equal to 0, so we could try. We could plug it in f of 3 into the original equation. So I have a 3 squared minus 3 minus 6, which is going to be 9 minus 9. That is equal to 0. Okay? So by the factor theorem, if f of 3 equal to 0, then the x minus 3, this is the factor of the fx. Okay, one more time. I have the polynomial. If you could factor out x minus 3 and times x plus 2. So these two are called factors. And then the 3 here, x equal to 3, and x equal to negative 2, we call this is the zeros. Or you could call this is the solution of f of x. Okay. Example 1. We do have a function x, the polynomial, and we want to know x plus 4 a factor. Okay, so by the factor theorem, if x plus 4 is a factor, then when we plug it in f of negative 4, it should be equal to 0. Okay, this is if and only if. So first, we're going to apply the symplectic division. Okay, and then we're going to look at the degree here. The highest degree will be 4. And then we skip 3, right? 4, we skip the 3, 2, 1, 0. When we're using the symplectic division, make sure you add the 0 as a coefficient for the missing term. And in the form, it should be x minus k, right? So k will be equal to negative 4. Now, we're going to bring down the 3 here. Multiply negative 4 times 3, we're going to get negative 12. Add it up, negative 12, and then multiply by negative 4. So you should get 48. Add it up, equal to 0. 0 times negative 4, which is going to be 0. Add it up, 8, and then there will be negative 32. So when you add it up, you're going to get 0. This is the remainder. Remainder equal to 0. That means f of negative 4 equal to 0. So x plus 4 is a factor of function x. Okay, right? Try to do the B. This time we want to know is x plus 4 a factor. Okay, so we're going to do the same thing, use the symplectic division. I want you guys to try. Okay, so you should get negative 40 as your remainder, right? So since f of negative 4 is not equal to 0, so x plus 4 is not a factor. Okay, last one. Factor f of x into linear factors, given that 5 is a0. Linear factor talking about you only have the x with the first degree, just like x plus 3, x minus 2, that's called linear factor. And then they given that 5 is a0. Okay, so we could use the symplectic division, plug in k equal to 5. So double check your work, use the symplectic division. So plug in 5 here. So you should get the remainder equal to 0. Okay, remember how to write down the quotient here. This is the quotient, right? So if this is x to the power 3, we're gonna subtract 1. So that will be 6x squared minus 7x minus 3. Okay, this is gonna be the quotient. So the function of x, we could write it down. We do have a one factor called x minus 5. X minus 5 times the quotient. If you try to distribute one by one, combine the 9 terms, you should get back the original question, like this guy. And then they want you to factor the function x into linear factor. So this is good. This is the linear factor because the x has a first degree. But this one, this is not the linear factors. This is a quadratic. So can you guys factor out this one using the x method? You should get this one. Okay, so this is called linear factor. All the x has the degree 1 here, degree 1 here. Okay, rational zeros theorem. If the polynomial f of x, this is my polynomial, has integer coefficients, then every rational zero of f is of the form p over q, where p is the factor of the constant coefficient a0, and then q is the factor of the leading coefficient an. Okay, we need to know this rational zeros theorem. Think about it for the previous example. They are not given about 5 is a 0. We need to figure out what is your 0 in this f of x. Alright? Rational zeros theorem help us find out the possible zeros. Okay, so one more time. The p will be the factor of the constant coefficient, a0. Q will be the factor of the leading coefficient, an. Let's try on this example. List all possible rational zeros of f of x. So first, we're gonna write it down. What is your p and what is your q? Okay, and p must be a factor of the last constant here, a0, which is gonna be your 4. And then q must be a factor of the leading coefficient. Okay, this is the highest degree, so the leading coefficient, an, will be equal to 8. So think about it. What is the factor of 4? You could do 1 times 4 or 2 times 2 to get the 4, right? Or you can do negative 1 times negative 4 or negative 2 times negative 2. So we're gonna write out all the possibility here. Okay, one more time. Positive 1 times positive 4, you're gonna get the 4. Negative 1 times negative 4, you're gonna get positive 4. Same idea for the 2. 2 times 2 to get the 4. Negative 2 times negative 2, you're gonna get the 4. Okay, how about the q here, the 8? You can bring it down to 1 times 8, 2 times 4. And that's it, right? And then of course it's gonna be plus minus for each one. Now we're gonna write down the possible rational zeros. It's gonna be p over q. Okay, p over q. So you could do plus minus 1 divided by plus minus 1, which is gonna be plus minus 1, right? Or you could do 1/2, 1/4, 1/8. Or you could do 2 over 1, negative 2 over 1, or 4 over 1, or negative 4 over 1. This is all the possible rational zeros from p over q. Okay, after you guys find the possible rational zeros, we're gonna find all the rational zeros and factor the f of x into linear factors. So how do you know which one is gonna be your zeros in here? You're gonna try plug it in to see any of this number. We're gonna make of f of x equal to 0. So usually we're gonna use the easy number, okay? We try to use plus minus 1, plus minus 2, okay? And then at the end, we're gonna try the fraction. So let's try 1, okay? K equal to 1 is a factor. So we're gonna use symphatic division. Okay, write down the coefficient of fx, and then we're gonna try 1 x equal to 1 here. So you're gonna find out the remainder is equal to negative 30. So 1 is not a factor. Okay, x minus 1 is not a factor. Okay, how about negative 1? Okay, I want you guys try plug in x equal to negative 1. Try it one more time using the symphatic division to see if you're gonna get the remainder equal to 0. Okay, check your work. Yes, negative 1 is a factor. Okay, and then now we're gonna write down the quotient. Okay, this is a x to the power of 4. So we're gonna subtract 1. We do have a x to the power of 3. So 8x cubed minus 34x squared plus 7x plus 4. Okay, make sure you write down the x plus 1 as well, okay? We do have a x equal to negative 1, which is gonna be the factor of x plus 1 here. We do have a factor x minus 1. We do have a factor x equal to negative 1, which is the factor will be x plus 1, and then times the quotient. Okay, we need to find all the linear factor. This is not a linear. So what can we do? We're gonna keep using the possible 0 from the previous. So now let's try x equal to 4. Okay, using this polynomial. So write down the coefficient of this polynomial will be 8, negative 34, 7, and 4. And then use x equal to 4. Okay, you're gonna get equal to 0 again. So we know 4 is a factor. So now my f of x become x plus 1 and x minus 4. And then what is this quotient? That will be x squared minus 2x minus 1. Okay, we factor out. Make sure you're gonna keep the previous factor, x plus 1, and then x minus 4, and then the quotient. Okay, this one, use the x method, factor out. You're gonna get this. One more time, this is called factor. X plus 1, x minus 4, 2x minus 1, and 4x plus 1. This is the factor. And what is the 0? What is the solution? You could think about it, let it equal to 0. So you do have x equal to negative 1, x equal to positive 4, x equal to 1/2, and x equal to negative 1/4. Okay, this is called the rational zeros, or you could call this as the solution of the function x. Okay, I want you guys try to do this one by yourself. First, write it down. What is your P? What is your Q? And then find out all the possible zero. Okay, P must be a factor of the constant A0 equal to 10, right? And then Q will be the leading coefficient, which is going to be positive 1. And then the factor of 10, it can be 1 times 10, 2 times 5, and then all plus minus. And then here, it will be only plus minus 1, right? Okay, write down the possible rational zeros, P over Q. So this one is pretty straightforward because we only have Q is equal to plus minus 1. So we can have a plus minus 1, plus minus 2, plus minus 5, and plus minus 10. So we're going to pick this number, either one of them. Use the symplectic division to see which one will be your possible zeros. Okay, so use the trial and error to find the first factor. I'm gonna try x equal to 5 first. Okay, you could try 1, -1, 2, or -2. Okay, but I just try x equal to 5. Okay, bring it down, multiply it, add it up to 0. So 5 times 0 equals 0. -5, and then -25. Add it up, -2. -10, and that's a 0. So 5 is a factor, right? X minus 5 is a factor. So now we're gonna write it down. F of x equal to x minus 5, and this is gonna be x cubed. And then we have a 0 plus 0 x squared minus 5 x minus 2. Okay, you could skip this one. Okay, now we're gonna factor out this one. And this time I'm gonna try -2. Okay, bring it down, -2, -2, and then +4, and then add it up, -1, and then +2. So this is a 0. So good, -2 is a factor. So we're gonna break it down one more time. So f of x equal to x minus 5 and x plus 2. And then the quotient will be x squared minus 2x minus 1. Okay, right? So, can you guys factor this one, use the x method? No, right? So you could use the quadratic formula, or you could use the computing square method. Okay, I'm gonna use the quadratic formula, -b plus minus square root b squared minus 4ac over 2a. So plug it in, simplify it. Okay, square root of 8, you could rewrite it to 2 square root 2. And make sure you don't cancel it, okay? Don't just cancel it, because this is a plus minus. What you're gonna do, factor out the 2 from the numerator. Take out the 2 here, take out the 2 here. And then now I could cancel it, because this is a multiplication. Okay, so I'm gonna rewrite this guy. This is x equal to 1 plus square root of 2. So you could subtract 1, subtract the square root of 2. So you got this guy. Another one, x equal to 1 minus square root 2. So we're going to subtract 1 and plus square root 2. So that will be the linear factor. And the rational zeros is just x equal to 5, -2, and these two guys together. Okay, fundamental theorem of algebra. Every function defined by a polynomial of degree 1 or more, at least one compressed zero. From the fundamental theorem, if f of x of degree 1 or more, then there is some number k1 such that f of k1 equal to 0. By the factor theorem, we have a f of x equal to x minus k1 times the quotient, the q1x, for some polynomial. If q1x is of degree 1 or more, the fundamental theorem and the factor theorem can be used to factor in the same way. That's a some number k2 such that q1, k2 equal to 0. Okay, we factor out, we take the q1 of x here and then factor out again. So we have a x minus k2 and then q2. Okay, so when we combine it together, your f of x equal to x minus k1 times x minus k2 and then the quotient. So assuming that f of x has degree n and repeating this process n times give, this is gonna be my function. We're gonna keep factoring. So x minus k1, x minus k2 until x minus kn. And the a will be the leading coefficient of function x. Each of these factors leads to a zero of f of x. So f of x has the same n zeros, k1, k2, k3 until kn. This result suggests the number of the zeros theorem. Number of zeros theorem. A function defined by a polynomial of degree n has at most n distinct zeros. So it depends on your polynomial. Let's say if you have a quadratic equation. Quadratic means you do have an x squared. That means at most you only can have a 2 0. Okay, at most you can have a 1 0 because this is a repeated. If you have a degree of 5, that means you do have at most 5 distinct zeros. Okay, this is called the number of zeros theorem. Example 5. Find a function f defined by a polynomial of degree 3. Okay, degree 3, so you should have at most 3 zeros. That has the zeros of -3, -2, and 5. And you also know the f of -1 equal to 6. Okay, this is not equal to 0, so -1 is not the factor, it's not the 0. Okay, so we only have these 3 zeros, and you know this is going to be degree 3 here. So when you have x equal to -3, we rewrite it to the factor, which is going to be x plus 3. How about -2? That will be x plus 2. And the 5? That will be x minus 5. And then we're going to let a be the leading coefficient. Okay, a will be the leading coefficient. So this is gonna be my f of x. I know all the zeros. Now, I'm gonna substitute f of -1 equal to 6 into these functions. We try to find out what is your a. Okay, plug it in. Simplify it. You should get a equal to -1/2. Okay, now we're gonna know the coefficient. Now we're gonna know what is the leading coefficient of a. We could plug it back to this function. And then we're gonna distribute it one by one. So this is gonna be my f of x. For the example 5, we try to doing the reverse. Okay, the previous example, I give you guys the function x, and then you're gonna find out the possible zero, factor out for the function x, and then find out the zeros or find out the solution. Now we're gonna do the opposite way. I give you the zero, you find out the factor, and then you distribute it, multiply it to find out what is your function x. Okay, try one more. Find a function f defined by a polynomial of degree 3 that has 0, 4 of multiplicity 3. Okay, 0, 4, that will be the repeat root. Okay, I have a 3 of them. Okay, and f of 2 equal to negative 24. So we're gonna let a be the leading coefficient, and then 0, 4, this means x minus 4. And then we're gonna multiply by 3 times. Okay. Now we're gonna plug it in. When x equal to 2, here, that will be equal to negative 24. And then we try to solve for your a. 2 minus 4 will be negative 2. Negative 2 to the power of 3, that will be negative 8. Simplify it, you're gonna get a equal to 3. So now I'm gonna plug in back to the function x here. And this guy, I'm gonna distribute it like 1 by 1. Okay, conjugate zeros theorem. If f of x defines a polynomial function having only real coefficient, and if z equal to a plus bi is a zero of f of x, where a and b are real numbers, then the conjugate, you're gonna see the line here, the conjugate of z will be a minus bi. It's also a zero of f of x. So this is talking about when you find the zero is a complex number, they always be a pair. Okay, they always be a pair when your f of x only have a real coefficients. For example, find a polynomial function f of x of least degree having only real coefficient. Okay, only real coefficients. And the zeros equal to negative 4 and 3 minus I. 3 minus I, this is going to be the complex number. And we just say that when we only have the real coefficient for the polynomial, the complex zero will be the conjugate. So think about it. What is the conjugate of this guy? That will be 3 plus I. Alright, so 3 plus I is also a zero of function x. So now we do have a 3 zeros, negative 4, 3 minus I, and then 3 plus I. Now we're gonna revise it to the factor. This one become x plus 4. This is gonna be x minus the whole thing here. X minus the whole thing here. Okay? So 3 minus I will be the 0. So we have x minus the 0. Okay, just like this guy. X minus negative 4. Okay, now we're gonna distribute the negative. So x minus 3 plus I. Negative, negative, you're gonna get positive. And this one, x minus 3, positive times negative, you're gonna get the negative. Okay, we could use the formula to distribute it for the second and third terms. This is gonna be your a plus b times a minus b. Remember the formula? A plus b times a minus b, which is going to be a squared minus b squared. Okay, now we're going to distribute it. Using the formula, a minus b squared will be a squared minus 2ab plus b squared. And remember, what is I squared? I squared, that will be equal to negative 1. Okay, now combine the 9 terms. And then distribute it 1 by 1. Okay, that will be your f of x. So keep in mind that if the polynomial only have the real coefficients, when you have the complex zero, then the conjugate of the zero will be a pair. Okay, example 7. Find all zeros of f of x. We do have the polynomial. And then we know that one of the zero will be 2 plus I. So by the conjugate zero theorem, when 2 plus I is a 0, then 2 minus I is also a 0. Okay, so now we're gonna use the symphatic division to divide by this guy. Let's do this one together. So we use the symphatic division. We have a 1, -1, -17, 55, and -50. So we have 2 plus I here. Okay, bring it down. We have a 1 here. So 1 times this guy, so 2 plus I. Added up, that will be 1 plus I here. Okay, now we're gonna multiply it. 2 plus I times 1 plus I. So we're gonna distribute 1 by 1. So we have 2 plus 2I plus 1I plus I squared. And then combine the 9 terms, that will be 3I minus 1, which is gonna be 1 plus 3I. So I have a 1 plus 3I here. Okay, added up, that will be -16 plus 3I. Okay, now, second one. We're gonna do 2 plus I times -16 plus 3I. Distribute 1 by 1 again. So you have -32 plus 6I minus 16I plus 3I squared. So -32 minus 10I, and this is going to be minus 3. I squared will be -1, okay? -1 times +3, that will be -3, which is going to be -35 minus 10I. Okay, I'm going to put it here. And then add it up, 55 minus 35, that will be 20 minus 10I. Okay, another one, 2 plus I times 20 minus 10I. Okay, that will be 40 minus 20I plus 20I minus 10I squared. So combine the 9 term, I cross it out. This is going to be plus 10, which is going to be 50. So I have a 50 here. So when you add it up, the remainder going to be equal to 0. Okay. So we have this one. Good. Okay. Now we're going to write it down this one. Okay, let me highlight it. We have this guy. This is gonna be your quotient. Okay. We have degree of fourth here. Okay, degree of fourth. So this is gonna be degree of 3. So you should have the quotient x cubed plus 1 plus I x squared. And then plus 3I minus 16x, and then the constant plus 20 minus 10I. Okay, that will be the quotient. And then we're gonna divide it by x minus 2 minus I. Okay, that will be the conjugate of 2 plus I. Okay, you're gonna do the same thing here. Okay, you're gonna get the 0 also. So you factor out, you do have a first factor x minus parenthesis 2 plus I and x minus parenthesis 2 minus I here. And then this guy, that will be the quotient, x squared plus 3x minus 10. Okay, now we're going to use the x method, factor out this guy. Okay, so that will be my zeros. This is called the factor, okay? This one will be the factor, and this is going to be the zero. The answer will be x equal to 2 plus I, x equal to 2 minus I, negative 5, and positive 2. This is going to be the zeros. That's it.